This is an interesting problem. Find the volumes of the solids obtained by rotating the region bounded by the curves y equals x and y equals x to the second about the following lines: A, the x-axis, B, the y-axis, and C, y equals 2. Let's get started. To find the volumes, let's start with part A. Part A is about the x-axis. To do that, let's do the graphs. And we do have the graphs y equals x in red. So that is y equals x. And y equals x to the second is in light blue. This is y equals x to the second. We don't need to graph the left side because that's what we want, the region bounded by the curves. When we go about the x-axis, so we should be going this way. And that will give me the other side down below, which is the following. That is the reflection of y equals x, and this right here will be the reflection about the x-axis of y equals x to the second. We're going to take a slice perpendicular to the x-axis, so we're going to use delta x. Once we use delta x, we're going to be integrating with respect to x, so we're going to be using dx. To graph the slice on the side, we could do the following. It's a washer that looks like this. And of course it's empty from the middle part. And we have the x-axis right in the middle. This is our x-axis. And this is our delta x. We're going to go from A to B. That's my A equals 0 and B equals 1. Now, to find the radius, we have inner radius and outer radius. The inner radius will be the smaller one inside to the blue curve, and the outer radius will be all the way out. So this is what we have. This is the outer radius, and this is the inner radius. So this right here is y2 equals x, and y1 is this part right here, which is x to the second. So R2 is y2, which is x. And that's this portion right here. That's my y2. Now y1 or r1 equals y1, and that is x to the second. And that is r1. This is r1. Now, the volume is pi integration from a to b of r2 to the second minus r1 to the second delta x, or dx, because we just mentioned that we are going with respect to x. That's the thickness right here. Equals pi integration from 0 to 1, because the slice will be going all the way from 0 to 1. R2 is x, and R1 is x to the second. And we're gonna go R2 to the second minus R1 to the second, all with respect to dx. Pi integration from 0 to 1, x to the second minus x to the 4 dx. Then after that it's all going to be regular steps of integration. Pi x to the third over 3 minus x to the fifth over 5 from 0 to 1. Pi 1 over 3 minus 1 over 5 minus 0, of course. We have the common denominator, which is 15, and on top is going to be 5 minus 3, which is 2, minus 0. So the final answer is 2 over 15 pi, and that should do it. That's for part A. For part B, about the y-axis, we still need to graph the function. We have y equals x in red, and that's y equals x. And we have y equals x to the second in light blue, just like before. But this time we're going about the y-axis, so we're going to go just like this. To graph the reflection on the other side, we will have the following. This is the red graph, and this is the blue one. Now we're gonna slice it against the y-axis. So this is a typical slice, and if you grab this on the side, we have the following. And of course, just like before, it's gonna be empty from inside. This time we're gonna use delta y or dy when we do the integration. Now, as before, we need to find R2 and R1 from the center all the way, that's R2, and from the center to the inner part, that will be R1. And of course, we don't want to forget the y-axis. The y-axis goes right in the middle, just like this. That is the y-axis. So what's R2? R2, we need to go back to the graph and write in terms of y. We have y equals x to the second, which means x equals square root of y. And for the red graph, we have y equals x. In short, x equals y. So the x amount that takes me for the outer radius is this much right here. This x right here is the outer radius, and that is R2. And that is x, the blue one, which is square root of y. And the inner radius is this much. This much right here is reaching the red graph, and that is R1. That is R1, which is x, and that is y, just getting it from this right here. Okay, so we have R2 and R1. Now we need to write the volume. The volume is pi R2 square minus pi R1 square with respect to y. Since we're using y, we're going to go from C to D. C is 0 and D is 1. So the volume is from 0 to 1. Let's take pi outside, and R2 square minus R1 square, all with respect to y. So dy. R2 square, or the outside radius, is square root of y. And the inner radius is y. Notice that we wrote everything in terms of y because we are integrating with respect to y. So that's the reason why earlier I rewrote everything in terms of as x as a function of y. After that, it becomes regular integration. So we have pi from 0 to 1. Square root of y to the second is y, minus we have y to the second, and dy equals pi. The integration of y is y to the second over 2 minus y to the third over 3. And it's kind of nice that we are just plugging 0 and 1 to save some time using calculations. So I have pi. Plug in 1, we get 1/2 minus 1/3. Plug in 0, you get 0. The common denominator is 6. We have 6 right here. Top part will be 3 minus 2, which is 1. And final answer is, the volume is pi over 6. And that should do it for part B. Now let's do part C. That's an interesting one, which is y equals 2. Different than before, x-axis and y-axis. First, you need to practice x-axis, y-axis, then you could move on to y equals 2 and x equals 1 and so on. Let's do the graphs. So we have y equals x, which is in red. That's y equals x. And the light blue, y equals x to the second. When we have about y equals 2, and this is y equals 2. This is y equals 2. And we're going to rotate about y equals 2, so we're going to go about this line. When you do it about this line, you're going to see the reflection as 2 dimension. instead of building it as a solid in 3 dimension. Let's grab the red one. The red one will be shown up here, and the blue one will show this way. Now we're gonna slice it this way down, which means we're going to be using delta x because we are perpendicular to the x-axis. Let's graph the washer, which is a washer on the side. The outer part will look like this. And the inner portion, the empty one, or the edges of the empty part, will be in red. So this is what we just talked about as delta x. And we have the middle part is just y equals 2. Now the volume is integration from a to b of ax dx, and this is my a, which is 0, and that's my b, which is 1. So we're gonna slice it all the way from 0 to 1 and cover them all. Now to do this, I'm gonna find a of x, which is a lengthy process, then I'll come back. So a of x will be pi r2 square minus pi r1 square. So it's going to be pi r2 square minus pi r1 square. Now let's focus on r1 and r2. The radius r2 will be from this point to this point. That's the outer radius, or r2, which is from this point let's go back and get the blue, from this point to this point. That's r2. And r1 will be from this point to this point. That's r1. So let's write r2 and r1. r2 will be 2 minus y1. And we'll come back and fix y1. And r1 will be 2 minus y2. Now here's y1, but y1 is the blue one, which is x to the second, and y2 is this right here. y2 is just x. To go back to r2 and r1, we have the following: equals 2 minus y1, which is x to the second, and r1 is 2 minus y2, which is x. Going back to the area a of x, that will be pi r2 square minus pi r1 square. And r2 is 2 minus x to the second, and r1 2 minus x. Simplifying this, we have pi. Using the distributive property, we could take pi outside as a common factor and do the following. 2 minus x to the second is like a minus b to the second, which is a squared minus 2ab plus b to the second. Or you could use the FOIL method or distributive, whatever works. So we have 4 minus 2ab, which is 4x to the second. B to the second will be x to the second, which is x to the 4. That is the first part. The second part, we took the pi outside. Same idea. So we have 4 minus 4x plus x to the second equals pi 4 minus 4x to the second plus x to the 4 minus, we're going to distribute the minus sign, minus 4 plus 4x minus x to the second. Let's see, anything cancels. I do have the 4 and the minus 4, and these two will be combined. Minus 4x to the second minus x to the second will make it minus 5x to the second equals pi. Let's put them in descending order. I have x to the 4 minus 5x to the second plus 4x. That is my a of x. Now going back to the volume will be from a to b, and we agreed that a is 0 and b is 1. Let's write that as 1. Let's take the pi outside since it's a constant. And inside we have x to the 4 minus 5x to the second plus 4x. Of course, with respect to x, we just mentioned that we are doing it with respect to x, equals pi x to the 5th over 5 minus 5x to the 3rd over 3 plus 4x to the 2nd over 2, which simplifies to 2x to the 2nd. And 0 and 1 will reduce our calculations. That will give me pi 1 over 5 minus 5 over 3 plus 2. We don't need to worry about the 0. Every term has an x in it, that's why. Simplifying, we get 8 over 15 pi, and that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.